Last video, we saw kind of a motivating example for the chain rule. Now let's do it more generally. And so if you read the textbook has Theorem 5 in there, which says that if our function has one independent variable with two intermediate variables, so w is a function of x and y are both underlying functions of t in some way. Assuming everything is differentiable, the derivative of w, so w is a function of x and y, but those are functions of t. Derivative of w with respect to t is the partial derivative of f with respect to x times the derivative of x with respect to t, plus the partial derivative of f with respect to y, plus dy dt. Note that these are partial derivatives. Those are partial derivatives there. This is w is a function of two variables, while dx dt and dy dt, x and y are a function of one variable, so I don't put a partial derivative there. So this is the chain rule for function of one independent variable with two intermediate variables. Kicking it up a step, here's the chain rule for if we have two independent variables and three intermediate variables. So w is a function of x, y, and z. X, y, and z are each functions of s and t in some way. So again, assuming everything here is differentiable, the partial derivative of w with respect to s, so w is a function x, y, and z, which are functions of s and t, is the partial derivative of w with respect to x times the partial derivative of x with respect to s, plus the partial derivative of w with respect to y, plus the times the partial derivative of y with respect to s, plus partial derivative of w with respect to z times the partial derivative of z with respect to s. And if you want to find the partial derivative of w with respect to t, it's the same thing here, but just everywhere we see an s, we put in the t's. So here's a second chain rule for two independent variables, three intermediate variables. And if you take a look in the textbook, there's a lot more of these kind of formulas, these kind of theorems in there. What happens if you have two independent variables and two intermediate variables? What happens if you have one independent variable and three intermediate variables? The textbook is going to have lots of different theorems that cover each of these cases exactly. But I don't want you to have the approach, when you're learning this information, I don't want you to have the approach of just memorizing all of these theorems one after the other, because really, computationally, there's a bigger picture way to do this. And so here's my algorithm I'm listing off here for how I would suggest that you carry out the chain rule. So the first is that you're going to draw a diagram that's going to show the dependence of each variable on other variables. So the dependence of your original function f on the intermediate variables, the dependence of the intermediate variables on the independent variables. Compute all the necessary derivatives or partial derivatives, and then for each top to bottom path that you see in your chart, multiply together all the derivatives, and then step 4 here is add up all of these products, ending at the correct variable. So let's do an example of this. So find dw dt for w is equal to x times y, with x is equal to cosine t, y is equal to sine t. So what's going on here? In our chart, we have w. W depends on x and y. W is a function of x and y. X and y are both functions of t here. And so step 1, we just did step 1 here is drawing the diagram, showing all of the relationships. Step 2 is compute all the necessary partial derivatives. So we're going to need the derivative of w with respect to x. So, because w depends on x, we'll need that one. We'll need the partial derivative of w with respect to y, and then x and y both will depend on t here. So we need those partial derivatives. Let's write out what these partial derivatives are. So the partial derivative of w with respect to x, the derivative with respect to x is just going to be y. The partial derivative of w with respect to y, the derivative with respect to y is x. And then we frequently want to write these terms, these answers in terms of t. So x is equal to cosine t, and y is equal to sine t. Now we need dx dt. Derivative of this is going to be negative sine t. dy dt, the derivative of this is cosine t. And so steps 3 and 4 says for each top to bottom path, multiply together all the derivatives and add up all of these products. So what we're going to do here, the w dt is equal to this times this plus this times this. There's two ways to get from the top to the bottom. So dw dt, the partial derivative, partial w partial t, times, partial derivative w with respect to x, times dx dt, plus the partial derivative of w with respect to y, times dy dt. And this is going to be, putting the pieces together, partial w partial x is sine t. Dx dt is negative sine t. Plus partial w partial y is cosine t. Times dy dt is cosine t. And so this is cosine squared t minus sine squared t. And so this is our final answer here. Let me point out, we go back to here, the chain rule for, we had this written here, so w is a function of f of x, y, x and y, so w is x times y, x is g of t, y is h of t. And so this formula right here is exactly the same thing that I copied out, more sloppily right here. So we could have just, skipped the picture here. We could have skipped the picture and just written down this answer, but the reason for me doing it in this way is to show you that you don't need to memorize this formula and memorize this formula and everything else here. If you just can draw these pictures, it can tell you what the formula is going to be. Okay, so that's showing out how to compute the chain rule. Next video, we'll do several more examples of this.